Hey everyone, in this video we'll discuss about that how you can insert any element at a given position of a single linked list. Let's start. So for inserting any element at a given position, what we have to do? We have to deal with a counter. So whenever you are trying to insert any memory at a given position of a single linked list, at first you have to take the node and you have to set the next pointer as null. Then what do you have to do? Then we will traverse through the entire list until the count variable is less than the position to be inserted. So we have to take the position from the user and we have to take a count variable. Now we'll see that how we can create a node. So for creating a node we need the structure, and then we'll call this function for creating a node, that is create node function. So we have talked about that in our previous video. Now we will look at the algorithm. So what is the algorithm? We'll talk about that and how we can implement that, what will be the dry run. We'll discuss about everything in this video. So we have written a function that is insert at any. Now as you can see that we have a global variable over here, that is node.head. So I have already talked about the significance of head, so why do we need head? Now at first what we have done, we have allocated a memory, that is temp, and we have called the create node function over here, and this create node function is returning the memory block to the temp. I think this portion is clear. Now we'll talk about that what is POS. So this is a position variable. So we will take this position from the user, so where we have to insert our data. So we have to take this position from the user. Now at first we will take the count as 1. In array our indexing starts with 0, 0, 1, but in list we will count that as 1. That is 1, 2, you can say 3. So the count of linked list starts with 1. So we have taken the count as 1. So we have to check several parameters for inserting an element at a given position of a linked list. Now as you can see that we have taken a reference pointer. So this t is a reference pointer, and we have also taken a previous pointer. So whenever you are trying to insert an element at a given position, you have to take a previous pointer. So you need this previous pointer for storing the previous memory address. So whenever we are trying to insert an element at a given position, we need two pointers. One is reference pointer, that is present pointer. Here we have denoted that as t. And you also need a previous pointer. So we'll talk about that, what is the significance of using previous pointer. So I think what are the purpose of using this variable is clear. So I think this portion is clear. So now we'll look at the checking part. So there are several checking that we have to implement. So at first we'll check that the position given by the user is less than 0 or not. So at first we'll check the position is 0 or not. So if the position is 0, then user cannot insert anything. So our list starts with 1, so we cannot go in negative, right? We cannot go in 0 or beyond. So that's why we cannot insert anything at 0th or any negative position. And then what we'll check? We'll check that if position is greater than count and head equals to null. So if our head equals to let's say that this is the head pointer. We have a pointer that is called head and it's null. So it means a list contains no values. So at first what is a count? Count is 1. So this portion we have done already. Now we are talking about this portion. So at first what is a count? Count is 1, right? Now we'll check that. Let's say that I have given 2. Now position, this position, user is giving this position. Now 2 is greater than 1. So can we insert any element at second position? If we don't have any value within a list, we cannot. So that's why we cannot insert any element more than one index if our head node is null. If our head is null, then how we can insert that? We cannot insert at second position, right? So that's why we have taken this parameter, that is position is greater than count. At first, what is the count? The count is 1. Now what is the position? Let's say that we have given the position as 2 or 3 or 4. So can we insert any element at second or third or fourth position? If we don't have any value within our list, we cannot insert that. That's why we have put these two conditions. If these two conditions or one of them is satisfied, then we cannot insert anything within our list. So if let's say that Let me remove all these things. Now we'll just print that invalid. So these are the invalid checking. Now if let's say that our head is null, head equals to null, then or head is not equals to null. Let's say that we have three values. Let me remove all these things. Yeah, so let's take two examples. The first example is head equals to null, and the second thing is we have three nodes and this is the head. So these are the two scenarios we have. So if we are trying to insert anything at first position, then what we'll do, our head can be null, our head cannot be null. Then we'll just write temp next equals to head, head equals to temp. So let's go for this case at first. Temp next equals to head means what? So we have, let's say that we have allocated a memory like this. This is the temp, and let's say 100 is over there. Now temp next equals to head means what? If our head is null, then we will also put null over here. Then what we'll do, we'll just put temp into head. Then it has some address, right? Let's say FFF0. Then we'll just assign that FFF0 into head. So what our head will contain? Our head will contain FFF0. Now our head will be pointing to this node. So this is how we can insert an element at first position when our head is null. And if our head is not null, let's take this case, then what we'll do, temp next equals to head. So let's say that it has FFF2. So we'll just put FFF2 over here. So it means temp next equals to head means now this temp is pointing to this node, right? Now then what we'll do, we'll just put or assign temp into head. So it means the value of head will be FFF0, that is the address of temp. So then head will be pointing to this node. So this is how head is pointing to a temp node and a temp node is pointing to the rest of the list. So this is how we can insert any element at first position, so if the position is given by the user. So I think why we are implementing these two conditions are clear. So now we'll talk about the concept of previous pointer. So these two portions are done. If you have any doubt, just write in the comment section. I'll try to reply you within 24 hours. Now let's go for the else condition. So now in this case, if we're trying to insert any element at first position, then what we'll do, we'll just go for this condition. So let's say that we are trying to insert any element at second position, or let's say that third position. Then what are the conditions that we have to implement? So we have to implement this condition. Now let's say that we'll insert an element at this position. Then what we'll do, we will at first, let's say that what is the value of t. So we have assigned t as head. Now at first, what is the value of t? So let me construct this list in a proper way. So let's say that its memory is let's say f0, our head contains f0, address of the second block is f2, address of the third block is f3. So this is the first block, this is the second block, and this is the third block. So we will insert an element at the second block. So how the list will look like then? Let's say that we'll store f6. So f0 will be pointing to f6, it will be the second block. Then f6 will be pointing to f2. This connection will be terminated. So then it will be third block, it will be fourth block. So this is the thing that we have to implement. So for this, what we have to do at first, so as you can see that we have assigned t as head. So let me remove all these things. Let's say that we have this list. Now at first we'll take a previous pointer which will store the value of t. Now at first, what t contains? At first t contains f0. Then we'll check while t not equals to null. T is null, t is not null. And what is the count? What is the count? Let me write this thing, that is t count and p. So at first p means previous, or let's say that prev. And in which position we'll insert? We'll insert at second position. So at first, what c contains? C contains 1. what t contains. T contains f0. T not equals to null. This is correct. Count is less than position. Position is 2, count is 1. Count is less than position. This portion is also satisfied. Then we'll assign t into previous. It means our previous will contains f0. Then what we'll do, we'll move t one step forward. Then what will be the value of t? The value of t will be f2, because t next means f2. So here we have f2, right? We have f2. Now t is pointing here. So let me correct this thing, that is 2 3. This is the first block, this is the second block, this is the third block. So then what we'll do, we'll increment our counter. So it means, now what is the value of counter? That is 1. Now it will be 2. Now we'll again check this thing, that is, now what is the value of t? The value of t is f2, but what is the value of count? The value of count is 2. So we cannot satisfy this portion, that is, count is not less than 4. What is the value of position? That is 2. What is the value of count? That is 2. So this portion won't be satisfied. It means we'll terminate this loop. Now what we'll do, we have a checking condition, that is, if position is greater than count. Now what is the position? That is 2. Now what is the count? That is also 2. So position is not greater than count. Position equals to count. So this portion will not be executed. Now at last what we'll do, we'll insert the element. Now what is the value of previous? The value of previous is f0. Now here let's say that we will insert this block f8. So this is a temp, let's say this is a temp. So we'll insert this f8 into the prev next. It means prev next means this portion which is pointing to f2. It will be f8. It will be f8. So let me remove this thing, and it will be f8. So it will point to this node. Now there is another step that we have to remember, that is temp next equals to t. Temp next means what our temp next contains. Now it's null, because whenever we are creating any node, by default it will be null. So now what t contains? T contains f2. So it will point to f2. Now it will be pointing here. So this is how we can insert an element at a given position. So as you can see that I have taken t not equals to null. In this position I can also take t next not equals to null. So I have taken this t not equals to null because here how many values we have. Let me clear this screen. So I have taken this t not equals to null because let's say that we have a list like this 1 2 3. If you are trying to insert here, we have already discussed. If you are trying to insert at second or third position, we have also discussed. But if you are trying to insert at fourth position, now fourth position means you are trying to insert at last. So if you write t not equals to null, then only you can insert at fourth position. If you write t next not equals to null, then you can only insert up to 3. So you cannot insert at last position. Last position means if you are trying to if you implement this logic, like this logic, then whatever, let's say you have 3 blocks, the whatever value you will be adding, it will be added into the n-1 block. So for inserting any element at last, let's say we have 3 value, we are trying to store at 4, then you have to implement this logic. So if you are trying to not insert any element at 4th position, then you can simply follow this step. So these are the minor changes that you have to look at. Now we'll talk about the coding. So let's start with the hands-on. Now as you can see in my screen, we have written hash include str.h, we have declared the structure, head equals to null, create node, we have written the insert, this is for inserting any value. Now this function is for insert anything at a given position. As you can see that we have written enter a data at a specific position, then we have taken the data, we have set temp next equals to null, we have taken the pause, this is the position, this is the value assignment, this is the invalid checking logic, we have also discussed that. This is the position equals to 1, it means we are inserting any value at position 1, and this is the logic. So we'll also discuss that t, difference between t and t next. So this is we have also discussed about this logic, and these are traverse functions. So at first what we are basically doing, let me compile this code. So at first we'll enter 10, 20, 30, 40. Now you can see that it's asking me for inserting any data at given position. Let's say we'll insert 999 at first position. So you can see that we have inserted 999 at first position, and we are again calling this two functions in the 89th and 90th line. So now let's say that we'll insert 888 888 after 10 and before 20, then it will be the third position. Enter. As you can see that we have inserted 888 after 10 and before 20 at the third position. Now, so I have already discussed that how we can insert any data at a given position. Now let's say that we'll insert that data at this position. So what is this position? First, second, third, fourth, fifth, sixth. We'll insert any data at sixth position. Let's say 666 at sixth position. You can see that we have inserted the data at sixth position. 1 2 3 4 5 6. So we have inserted data at sixth position. So I think this portion is clear. Now we'll see that how we can insert any data at last. 1 2 3 4 5 6 7. If we insert any data at 7th position, then it will be inserted before 40 and after 666. So we have to put 8. Let's say that we'll insert 777 at 8th position. So you can see that we have inserted the data at last. So we can insert the data at last because we have written t not equals to null. If you write t next not equals to null, t next not equals to null, it means we cannot insert the data at end. Let's say that 10, 20, 30, 40. Let's say that let me insert anything at first, 888 at the first position. So this is the list we have this list. Now if we are trying to insert any data at sixth position, so 6, it will say that invalid. We cannot insert the data at sixth position because how many values we have? We have 888, 10, 20, 30, 40. We have 5 values, so we cannot go beyond that. So if we are trying to insert anything at fifth position, let's say that 8899 at fifth position, then we can insert. So we can only insert up to n-1, so we cannot insert after that. So this is the difference between t and t next. Now the choice is up to you that how you want to implement. You want to insert anything at the end, or do you want to insert anything at n-1. So this is up to you. So I think this portion is clear. I have tried my best to explain this, how you can insert any element at any position of a single linked list. If you have any doubt, just write in the comment section. See you in the next video.